Well, here it is, guys. Our next project. Um, it's a face I haven't seen in almost 30 years. Um, a buddy of mine I played in a band with gave me this amp, oh, in the early 1980s, I would say. And I didn't play a whole lot of guitar, so I didn't use it very much. And as you can see, it's in some pretty rough shape right now. And the amp, I took it over to a friend of mine's house. Two of my friends are very avid guitar players, or were at some point in their life earlier. And I took it over to one of those guys' house, and there it sat in his parents' house in a closet for almost 30 years. And Brad the Guitologist, if any of you have ever watched his channel, great channel, and he is a fantastic guitar amplifier technician and guitar repair technician. He just did a recent video on, well, at least one of the variants of this amplifier. It is an Ampeg Gemini, or Gemini, however you want to pronounce it, Gemini 2. And there were different versions of this amp that had different output tubes, different speaker configurations. They all, some of them were G12 series, some were G15s. You can see this one here is a G15. And this is actually kind of a little bit of a more rare one, I think, because it has the Jensen 15-inch, and it's not a bass speaker, it's actually a 15-inch guitar speaker. It actually sounds really, really good, if I recall correctly. Now, when this 30 years ago went to my friend's house, it did have all the knobs, and it was a lot cleaner than it is now, but it's amazing this thing even exists at all. My friend said that many years ago he plugged it in and turned it on to try it out one day, and it just kind of quit working. And so the first thing I checked when I got this thing, when he dropped it off, was yep, the fuse is pooched. So how did I get this? Well, I kind of forgot about it, to be honest. And my friend works in one of the hospitals, and my mother was in the hospital over the last weekend, and my friend actually was assigned her room. So we were sitting and talking. He came in to chat with us when I was over visiting her. Don't worry, nothing's wrong with Mom. She's home. Everything's good. And I just had asked him about this. I said, "Do you still have this?" And he says, "Yeah, it's at my mom's house, and it's down in the basement in a closet. And they have a finished basement. It's heated. It's really nice, dry." So I said, sometime you ought to drop that off. Well, I never dreamed he would just the next week show up and say, "Here you go." So here it is. Definitely an old friend from a long time ago. So, well, now I got a little bit of a bite from the nostalgia bug. So I figured, well, I think it's a good one to do a video, and let's fix this up. So you can kind of see behind here what it looks like. And it's had service done on it even before I got it. The back was missing. The speaker actually was in perfect condition. I don't know what it's like now. It does have the foot switch. Has the original, there you go, the original power cord, all that good stuff. It has 71 or 7591 output tubes, kind of like our ICO amp that we did the video series on. Here's a guitar I built from scratch. I even made the neck. Again, it's probably all out of whack and needs a setup and everything. But I just, I don't do this stuff too much anymore. But I thought it'd be a good video, and I thought it'd be a lot of fun to redo this. I'm not sure what I'm going to do with it yet. I think probably the first thing to do is take it apart, get the chassis up on the bench, and see what's wrong with it. And then maybe we'll go from there. The other thing I found out was it's not so easy to find the correct. There's all kinds of schematics for Ampeg amplifiers out there, But this one here is a little bit strange. It was a little hard to find. As you can see, this one has the accordion inputs. And actually there is a difference between the accordion and the guitar input, the gain and so forth, if I recall. But you know, with the 15-inch speaker, they made this with I think there was ones with the 7591 outputs. There was ones with a 7868, which is kind of like it's a little newer tube that they moved to after the 7591s got phased out. And I think there's one even floating around out there with a 6L6 output. So other than having to find a knob, we're going to have to, and I don't remember what this was. I don't think this is the foot switch. It might be. I can't remember, or I don't know if this was maybe an add-on. I just can't remember. So, yep, let's get it on the bench and let's see what it looks like. Oh boy. You know it's bad when I start out with that phrase, huh? So I got this thing pulled out, and right immediately I see a whole bunch of things running through, you know, that are running through my mind. First of all, this amp has been worked on a lot, looks like, in the past, and I don't recall that I ever did any work on it, because again, I didn't play it a whole lot. And a friend of mine that was a drummer had this amp, and it was his dad's, I think, or his dad's friends, and they didn't use it, and they gave it to me, and it sat, and then I gave it to my one guitar playing friend, and it sat. And so this really looks like in its previous life had a pretty hard life. Obviously, when we look at this capacitor here, it looks like it's just a filter that's been added. It looks like the diodes have been replaced. Just kind of did the hook and pinch thing, looks like. Looks like a resistor was replaced at one point in time, and it was replaced with, what is this? These are 100K, so that would be 200K. Not sure what that is. Maybe a bleeder or something. I don't really know. Of course, that's going to the, that looks like it's going to the AC side of the of the rectifiers. This can capacitor maybe looks like it's been replaced. I don't know. Yeah, I think it was, and parts of it have been clipped out. Must have been bad sections and was replaced with that one over there. But all of those things are superficial. They can be repaired. The one thing that's going to be a real challenge on this is, and I didn't know. I mean, I didn't know that they did this on these kinds of amps. But if you look through here, all over the inside of this amp, you look down here, if I go down close, see that? These are all the wires. And if you look down in here, all this, see that? If you look on the tag board, look on there, they use that glue, that stuff that you glue all the, you know, like you see on a lot of the amps, a lot of the receivers that we work on from the 70s, if you recall, you know, they would put that glue on, that horrible, you know, metal eating goop that corrodes everything. This whole amp is just coated in it. Take a look. Everywhere you look, just all the way across, everywhere, just covered with this stuff. So what we're probably going to have to do, well, it's not probably, it's what we're going to have to do, is clean this stuff off. You can see already where that stuff is. We have a lot of, you know, you have rust getting in here from all this. Strangely enough, the front faceplate, other than being dirty, you know, the chrome is still good. It's not pitted or anything. It looks pretty good there. But definitely definitely we have issues with, with all the rest of this stuff. Now, these capacitors here almost look kind of like modern, film capacitors, but they're probably not. This all looks original. None of this looks like it was ever replaced, at least that I could tell. Of course, now I look here and there's some things under. I'm not sure. I'll have to really look at this thing carefully before I make any statements about it. But I guess we're just gonna have to start at square one and just clean everything. I really don't feel comfortable leaving wires like this in here because, I can see already right here where the wire's cracking and breaking. And I see that people have taped it, put on some tape. So, yeah, got our work cut out for us on this one. I would call this one, again, another basket case. So, but it's all here. The whole amp is here. The chassis looks pretty sound. This is a relatively complex amplifier. You can see all the parts on the tag board. So we're just going to have to go through and kind of photograph and map everything out and see where it's at. And I guess we'll just go from there. Take our first step, and that's how we'll start the journey. So, all right, let me get some housekeeping done on this thing, and I'll be back. All right, so the first thing that we kind of have to do here, a little bit of kind of finding your way around, is to look at the power supply, because obviously the fuse that was in there when I picked this, when he brought this over, the fuse was the first thing I checked, and it is completely obliterated. Now, one of the problems at hand was I had to get a schematic for this thing. So the first place I turned is my trusty old book. Now, I've had this book for probably since I was probably 10 or 12 years old, literally. I have my one cousin, not the one that worked in the in the pinball machines and jukeboxes and video game industry, but the one that got into the X-ray industry, where I ended up. He started his life out as a bench tech. He worked for several places, including Lafayette Radio Electronics, and he had a lot of this stuff. And when I first started getting into electronics, this was one of the first. He had this book and he gave it to me, and I've had it ever since. And I've used it for years and years, and it's kind of like the old standby. If you have an old 60s or 70s guitar amp, chances are that amp or some variant of it is going to be in here, and it's just loaded with schematics of every kind of guitar amp out there. And the neat thing is they made several revisions of this book. There was another one in our public library that had a blue cover, and it had a few more schematics that this one didn't have, and this one had some that it didn't. I may want to pick one of those up someday too if I ever see it floating around on eBay. But the first thing I looked at was I went to look and see, thinking, well, maybe I'll luck out and it'll be in this book. And I kind of flipped through it, and there is an Ampeg G12, but no G15. And the G12 does have the 7591s, but as you can see, the power supply definitely doesn't match. There is a bridge rectifier in this one, and obviously the one we have just has a full wave rectifier with the center tap acting as the ground on the transformer. Now, the other issue is what voltages are these amps working at? Because obviously the capacitors have been replaced. I looked at some of the date codes. It looks like most of the components on this amp were built in 1968, including the transformers. And I did see a engraving on the capacitor that looked to be 1968, so I'm assuming this one was original. However, there is some discrepancies on the capacitors. So then I started going online, and the first one that always comes up on all your searches is this one here, and it says Ampeg Gemini 2 model G15. And this, of course, is a Gemini 2, and it is a G15. But first problem is this one's using 6L6 output tubes. Second problem is this has a bridge rectifier instead of a full wave rectifier and no center tap on the transformer. It has a hum balance pot, and it's using a capacitive dropper to create the negative 50 volt bias voltage. So there's quite a few discrepancies here. So this is definitely not our amp. I didn't even get into this part, but I'm kind of thinking maybe even some of this might be a little bit different. So I went through and I found these ones. I'll show you this one first. Very hard to read. Again, this one's scattered around the internet, and I checked a couple Ampeg websites that deal with that, and a couple guitar amp websites. These seem to be the garden variety schematics that everybody's sharing around out there. Again, bridge rectifier, capacitive dropper, and the capacitors don't match. And the big thing that concerns me on this one, again, we're dealing with 6L6s, and again, they're calling it a G15 Gemini 2. That's what they're all saying. But the capacitors, the first one's rated at 600 volts. The one that I had in there obviously was replaced, but it was 450. No wonder it probably failed. But the rest of them are rated at 500 volts. And this, what appears to be a stock capacitor down here, is obviously, it says 450 volt. And then nowhere do I see the two 20 microfarads, this firecracker cap, that are 20 and 20 at 450 volt. So this is definitely not our amp either. The next one I found was one of these that was redrawn once again. Again, G15R, and this is a Gemini 5, so definitely not the right one. But it has a little bit, it's a little more similar to what we have. It has the 7591 outputs. It has the full wave rectifier instead of the bridge. It has a resistive dropper, which is 220K resistor for the negative bias. And if you look, this has two 100Ks in series, which would be 200K, close to that 220K. So that's close, and I'm assuming that was not factory. Somebody put that on there at some time. However, this one has an adjustable bias, and ours has a non-adjustable fixed. These are both fixed bias. Fixed bias just means that you're putting this bias voltage here to bring it up rather than cathode bias. But once again, it is not an adjustable fixed bias. It's a set one. It doesn't have this pot. So this part doesn't exist on the amp that we have here. There's also a balance pot, so you can balance the bias at the cathode end with a 100 ohm resistor. I don't have this either. So this may be either a modification that was done down the road and somebody drew it when they drew this, or this could very well be a later revision of the amp that I don't have. So, but so far this looks pretty close. But once again, the capacitors don't match, because I have, here's the two 20s at 450 volts, but we have a 40, and an 80, and actually this one, this is 40, 40, 40, 40. There's four 40s in here. Two of them are tied together. That gives you your 80 microfarad. So that might be what they were talking about. So that's correct. However, once again, we look at the voltages. We're looking at 600 volts for this. So it's almost like it was a separate cap. And then 500 volts for the other two 40 microfarads. Well, all four of those in that can are 450 volt. Now there's no mention here of actual voltage. We don't know what the primary of this transformer is putting out. Because if you remember, whatever we're reading from the center tap to the end in this configuration, AC wise, you have to times that by 1.414 to know the peak voltage that this capacitor is going to see with no load on it. And so that's where we are. The only way that we can figure this out for sure is to measure the transformer. So that brings us to where I am right now. All that conversation, I've removed the two secondary leads from the tag board, and they go straight to the secondary of the transformer. I put a smaller fuse in here, just a 1 amp instead of a 3 amp, and I connected this up to my Variac through these leads here, and I'm going to measure the output. Now, okay, so quick update what's going on here. I've done a little bit of research, and again, I'll be the first to admit I am not a guitar amplifier expert when it comes to knowing the dates and the manufacturing days and all that of these. Of course, there are several very good sites that you can look up some of these things based on serial numbers and codes written on the transformers. This machine, you know, the serial number, at least from what I could glean from the internet, and of course we know how much we can believe the internet all the time, but sometimes we get good stuff. The serial number on this seems to be a 1965. And being that this uses the 7591 outputs instead of the 6L6 outputs, that would probably date this as a older version of the Gemini 2. Just because it says G15 Gemini 2 doesn't mean it's exactly the same unit. There were several different iterations of this, and a lot of the material that I downloaded from the free sites, you know, all the basic ones you go to, none of them really matched this system. So I finally decided I would just kind of take the plunge, and I went to musicparts.com's website, and it's a pay site for their service manuals, but they actually have a little bit more complete data. And I was able to find what is very, very similar to what I have here. And it even has things like the tube layout. It has measurements, all the different measurements for the transformers and so forth. And of course it shows us that it's 720 volts at that's with and they're showing this one is 240 volt input, but of course this one's set up for 120. Oh, I'm sorry, right here they have two versions, but they're showing it 117 volts. It puts out 720, which is, I guess that's pretty much in line. When I put 125 volts into it, I was getting a little higher than that. I'd have to go back and check the last clip for that. But bottom line, this is also a reason I believe this is an older unit, is that the original filter capacitors on this were rated at 450 volts. And when I look even at this older one, when you get to the schematic section, this is interesting. They are showing the regular full wave rectifier instead of the bridge, but they're still showing the bias adjustment, where mine is not adjustable. It is fixed at 1 voltage, and there's no adjustment pot. So I think this is an older revision even than this one. The other thing is they're showing these capacitors. They're the correct ones now, but if you notice, they're showing them as 500 volt caps instead of 450s, and that also leads me to believe that, you know, these were 450s. They were undersized, and basically when this thing was turning on, what was going on was that it would exceed the voltage. You know, so when you first turn this on, before the tubes warmed up, we weren't going to have our 430 volts, which a 450 volt cap would be good, but it was up around 500 volts or a little over. So again, I really, I ordered a new CAN capacitor for this, and it's rated at 525 volts, so it'll be just fine. It should last a very long time. So a couple of the other things I liked about this manual that I purchased was it has all the tube resistance readings. A lot of the old radio manuals that you see out there have this. This is a great thing. We can measure the sockets for the static resistances. It shows voltages for the sockets. And really cool thing is they show that little couplet or couplet for the tone control. It actually shows you the schematic of what's inside that little module. And you can see that right down in here. If I zoom in, you can see that right there, the little couplet. So now we know the actual component values in there. So this is looking a lot better now. And I did order, like I said, a couple components. In the meantime, I'm just replacing these parts and just going along here. Once I get it to a point where it's ready to power up, I'll put power on it and just check voltages. So as soon as we get to that point, I'll be back. Okay, we're back now, and it's been a while since I've been here on the bench, so just trying to remember where I left off with this on the last clip. Probably could play it back, but of course I'm too lazy. What I've done is I've completely rebuilt the power supply, and as you've also noticed, I've replaced these, or may not have noticed, I replaced the two output tube sockets. And the reason I did that is the old sockets were pretty rusty. If you recall from the earlier part of the video, there was a lot of that glue and a lot of corrosion and dirt and rust and everything. I wanted to get that all out of there. I also replaced the power cord with a modern 3-prong cord, and because we've done that, there is no need to have the double pole, double throw, single, center off standby switch. So I just went to a single pole, single throw, nice heavy duty switch for the standby. All of the mess that was in here has been cleaned off and redone. I'm using my silver plated Teflon coated wire, which is very good. The stuff will last forever. It won't deteriorate. It's heat resistant, all that. New dropping resistors, all same or bigger size than the originals. And a different bias circuit, totally different bias circuit. And I did that for a reason. If you recall on the original schematic, let me see if I can dig it out here for you. Okay, I thought I had a schematic showing this, but I don't. This has really been quite interesting on this Gemini amplifier in that there are a bunch of different variants of this amp, all called the Gemini G15 Gemini 2, the Roman numeral 2. There's a whole series of Geminis from the Gemini 1 all the way up to, I think there was a 5 or 6 or something like that. There were quite a few of them built, but the Gemini 2, there were different variants. Ones that used the 7591 output tubes, and other ones that used 6L6 tubes. They all had fixed bias, but some of them had adjustable fixed bias, and some of them had non-adjustable fixed bias. So you didn't have a pot to actually, custom bias your tubes, your output tubes. The other thing I noticed was, if we move over to here, this little yellow wire and this blue wire, there's a resistor here, and then over here is another resistor. These are your two bias resistor, or fixed bias resistors that split off to the grids, and you can see it comes right off your negative bias supply through the resistor and out to your grid resistor, and for your grid leak. And if you go back in the video, the original design, we just came directly off of the power supply, directly into this, and whatever the voltage was, it was. Now, all the schematics that I saw, and I'm going over all this, you guys can skip ahead if you're not interested, but this is for people who may have one of these and want to service it. What I found was very interesting. The only schematics I could find that showed a non-adjustable fixed bias had a 270K resistor in here and in here. The ones that had the adjustable fixed bias with the pot had a 100K resistor in there instead of a 270K. This one had the non-adjustable fixed bias and it had 100K. These are originals in here and they're still reading perfectly. So I didn't really have to change those because that's what the adjustable circuit calls for. Now the other thing was over here, let me move over, where they're deriving power for the negative bias supply is right off of your power transformer. And by the way, I will have a completely accurately redrawn schematic I'll show you later in the video. I'm still working through it, getting it correct. I don't want to show anything that's not correct or that I'm still working on until till it's right. But a lot of them use just a 220K resistor to drop that AC voltage down to a reasonable level, and then it goes in here into your bias supply. And underneath this capacitor, you can't really see it, but there's just a 1N 4007 diode in reverse bias, backwards, to give you the negative voltage. And then you have it's a very unique circuit the way they do this. Well, not unique, I've seen it before, but what they're doing is they're creating the voltage here, and then they're just shunting this resistor in series with your adjustment pot here, and by varying the shunt resistance across the power supply, it's just kind of clamping it down because it's current limited by this, or by what was that resistor in there. And that's how you can adjust your bias, your negative bias voltage. Now, there were some later versions of redrawn schematics that I have a feeling were like modified versions of this amp, where they used a capacitive dropper instead of a resistive dropping. And so I kind of borrowed a page from that redrawn schematic, and I used a capacitor instead of a resistor, so we don't have to deal with the heat and temperature changing and stuff like that. They were using a 0.047 microfarad. I ended up getting a 0.033. Seemed to be a lot more in line. The voltage was just climbing too high with the 0.047. With the 0.033, it's pretty good. Again, I have not fitted any tubes in this yet to try it. I haven't even tested the tubes on the tube tester yet, but we're going to do that next. The other thing they put in was just a 100 ohm pot right here, and it's just kind of the center tap of the pot goes directly to ground, and then each leg of the pot goes to the cathodes of the output tubes, and it just gives it doesn't really cathode bias it, obviously, but it just allows you to have a little bit of difference that you can adjust this in case the tubes are not totally balanced. Now, in the old amp, the old design, because it was a non-adjustable fixed bias and you didn't have a bias balance, you had to A, have very accurately matched tubes, and B, you had to have tubes that were suitable for that fixed negative voltage, which I think it was fixed at like negative 50 volts, which is pretty high. I mean, that's some pretty high, not totally high, but it's just kind of an arbitrary voltage that you can't move. I mean, if you needed 45 volts or negative 60 volts or whatever, you couldn't get it without changing resistors. So this is a much improved bias circuit, I think, and it's kind of an amalgamation from different versions of this amp that I chose. I went with some big 1,000-volt diodes. They're kind of oversized and overkill. I didn't have any 1N, 5408s or whatever, the 3 amp 1,000-volt. So I just used what I had on hand. A lot of this is stuff I just had on hand and I used. Let's talk about something else here now. The output capacitors. If you recall, the caps that were in here were really bad. They were 450 volt and they were way undersized. Even though this power supply is going to drop down to about 430, 440 volts once the tubes are all settled in and heated, when you first turn the amp on, because this is a solid state rectifier, the voltage actually goes clear up to almost 520 volts. And that's because it's seeing the peak voltage, not the RMS voltage, when the amp is not loaded. So these caps were way exceeding their power rating every time you turn the amp on, which was not, it just broke them down. So the very first capacitor, and again, we're going to see a schematic of this, I went with, instead of trying to find a gigantic, very overpriced, expensive capacitor, they're calling for 80 microfarads, so anywhere between 80 and 100 microfarads would be okay here. To find one that can go up to 525 volts, they're expensive and they're kind of awkward shaped and everything. So what I did was I took two 220 microfarad 350 volt caps that are 105 degree, really good quality, that I had on hand, and I put them in series. And I did not put a bleeder resistor across, balancing resistor network across them, because at 700 volts they're way over. Even if the ESR is not perfectly matched in them, it's not going to hurt it. I did put one bleeder resistor across the whole network, but of course that's not going to balance them, but it'll bleed them off when you turn the power off. That's the only reason that's there. Underneath, this is the real interesting thing. You guys may have seen these used in other videos, and you see them for sale at a lot of the parts houses. The CE Manufacturing. It's one of the companies that is making modern reproduction can capacitors. I've read a lot of reviews on these, and there's been a lot of negative feedback about these being they short out, they're very high ESR, they have problems. I've done about 5 or 6 of these now. 2 of them, including this one, did exhibit the problems that I've read about. I'm just telling you guys this up front so that you can kind of watch out for it. In both cases, though, for some reason this is a brand new capacitor, but even being brand new capacitor, it just acted like they weren't formed. I don't know if they build these caps and then they don't properly form them in the factory before they go out or what, but I had to apply stepped voltages from this over about a 2.5 to 3 hour period, starting at about 100 volts. These things were almost acting like shorts at about 250 to 300 volts. No kidding. They were that bad. And they're rated, if you look, 40, 40, 20, 20, all at 525 volts. I wasn't even getting half of that. So as I was stepping the voltage up, this cap got warm. I mean, it got warm to the touch. You could feel it. But after about 2.5 hours, all the current dropped down to nothing. The capacitor cooled off, and now I can put 525 volts on this thing all day long, and this cap works perfectly. So I think some of the complaints that came about with these was that it just out of the box, these will not work. At least sometimes. At least 2 of the 5 or 6 that I've done have had this issue. But you can, I don't want to say you're reforming them, because I don't know the caps were ever formed to begin with, and I don't even know under the building process of a capacitor if they just work right out of the box or if you do have to form them. I don't know. I've never really studied that, but all I know is these ones did form up perfectly, but when they came from the factory, they didn't work. And I don't like that, because obviously I would expect a brand new product. These things are about 40 bucks US. That's a lot of money for a capacitor that doesn't work, and I had to spend 2.5 hours reforming it. But it works perfect now. I've not had any problems with it. Power supply is working great now. So we're almost ready to put some tubes on here. I know I'm getting long here with this clip, but I went over and kind of randomly pulled some of these capacitors. Every one I've checked so far has been good. No leakage. All the resistors are pretty spot on where they need to be. These little couplets or couplets, whatever you want to call them, right here, there's one there and one over here. I have obviously not checked it, so I don't know if they're good or not. Sometimes they work, sometimes they go bad and you have to replace the components. But luckily, when I purchased that service manual for this, it does show a schematic of these. So if we have to build a little network, we can do it. So there we go. Power supply is ready to go, and the voltages are all good. So I think the next thing we're going to show is I'm going to test the tubes, and I'll show you how I test those. And I do have a new set of tubes for this amp. I think I have all of the ones I need. I should, because these ones I think are dead. As you can see, all the dark spots right there, that's usually a sign that they've arced or gotten hot. There's some discoloration on the getter up here at the top. This one here, you can see some kind of welder's flash, you want to call it, but you can kind of see where it, you could see like where metal particles have, you could see right on the glass where it's sputtered onto there. It's not good. So I think these tubes are dead. So these realistic lifetime tubes, they're at the end of their lifetime. So wonder what Radio Shack would do if and you could see on the top of this one the big burn mark. Wonder what Radio Shack would do if I emailed them. I've read that they will try to honor it and try to replace them, but who knows? Maybe I'll try that and report back. Okay, we have the old Heathkit TT1 tube tester out, and I have it set up to test the 7591s. And an interesting story about this. This thing is, totally mint condition on the inside. It was assembled. Whoever built it did a fantastic job. The soldering and everything was just textbook. It was awesome. But it didn't work. And I don't think it ever worked properly. I ended up purchasing this online. I got a good price on it. And I found a couple little errors in the construction that when I fixed them, it began to work just fine. And then I went through the calibration process, calibrated up perfectly. So again, when a kit is assembled and it doesn't work and people get frustrated, that's a good thing for us, because usually what happens is it doesn't get used. So all the switches and all the parts inside just kind of sit, and eventually they get frustrated and want to clean out their attic or their basement, and you end up buying it and you get what's essentially a new tester. So that's kind of the case with this thing, and it's been a very good tube tester over the years. It is a mutual conductance. It does a pretty good job. There's a lot better ones out there, but for what I do, it works really well. Now, a couple interesting things is kind of how you use this. If you look at, let me see here. If you look at the little chart, it kind of tells you how to do, how to set the knobs and everything. But the remarks section is the one you really want to be interested in the most. And there's a couple little codes there. PE just means that it's a pentode tube that you're testing. But this X6 means you take your measurement when you're checking the conductance, and you have to multiply it by 6. And then this RP is your rejection point. In other words, any number below that number is considered a bad tube. So anything under 1100, now remember, 1100 on the scale is going to read 1/6 of that. So you have to take your 1100 divided by 6. So really, anything under 17, which is going to be at the top here, way down here, anything under 17 is going to be a bad tube, which I would even say that's a very generous. It should be a lot higher than that. But anyways, if we look at the meter here, let me see if I can get the lighting a little better. This thing's kind of sits funny on the bench. So if I hit the test, you can see this is 100, 200, 300, about 350, and then you times that by 6. So 350 times 6, where technically this would be a good tube, although it has a lot of wear looking on it and so forth. This tube at least is showing that it's conducting and it's functional. If I go through the grid, screen, plate, suppressor, and cathode, there's no shorts. There's this little knob down here. As you rotate through that, if there's a short, it'll kind of show up on there. So this tube technically is at least functional. Now we're going to put the other one in that I think is shorted, but I don't know. I haven't tested it yet. It's definitely had a lot of stress. We're going to turn it on, and we're going to set our line, make sure it's still on. Let the tube heat up a little bit, and while it's heating up, I'm just going to check for leaks again. And there's no leaks or shorts that we can see anyways. And as you can see, it does conduct a little bit, and it's actually creeping up. So technically we could put these tubes in there and they would most likely work. Now, you know, a tube tester like this never puts the high voltages and high currents onto the tube that you would get normally with, you know, in a real circuit, but it at least gives you an idea if the tube's working or not. So, and you can also, if you do the mutual conductance test, you can somewhat match tubes, although there's a lot more accurate testing to do that. This is just a very rudimentary way to match tubes. If you're into major high-end audiophile amplifiers, this probably would not be suitable for matching tubes. But for what we do here, it's fine. So you can see it's creeped up a little bit. Now, I also have a brand new tongue saw 7591. This one's brand new, never used. And again, if we do, where are we at? Make sure our line is good. I'm looking through the viewfinder here. And if we check it, let it heat up a little bit. You can see it is considerably higher conductance than those older tubes. So you can tell those old tubes are somewhat depleted when you compare them to a brand new tube. If you take that number and where are we at right now? We're about 925. Does that say? So that'd be 5550 would be the mutual conductance on this, and that would be in micromhos. So it'd be 5,550 micromhos. And let's take another one of these brand new ones and take a look at it and see. Okay, I have the other brand new 7591 in there, and these were rubber banded together, so I'm thinking, I mean, these ones are supposed to be matched. So technically it should be somewhere around that 5,550, which means it should be about that 925 again. So let's see if it's warmed up. You can see that one's even a little bit higher. It's more like 6,000 or so, a little over 6,000. So they're both pretty high gain, and they're both very good tubes. They're brand new, like I said. But you can see at least we verified that those other tubes are not dead shorted and that they do have some conductance in them, even though possibly they're weak, obviously. So there you go. I just thought you'd be interested in seeing that. I'm going to go through and test the rest of these tubes, especially this, where's it at? I think this, somewhere, this one. This is a original tongue saw 7199, and this is a very hard tube to find. I mean, they're out there, but they're getting really expensive, and you're not getting a lot of choice on them. This one's a really nice one, so this one I'm very interested in seeing what kind of condition it's in. The rest of them, you know, 12AX7s and things, we got those around, but this one here is going to tell us whether we're going to have to make some changes to the amp or not. So let's check it. Okay, we have the 7199 in there, and the first thing we're going to test is the pentode section, and it's saying that the mutual conductance should be, the rejection point is 1500, and we want to multiply the reading by 3, so anything over 500 down here will be would be a good tube. Okay, because 500 times 3 would be 1500. Just kind of explaining this for you guys that are new to this. And you can see we're way over that. So this one so far is really good. Now this is the pentode section. Now we have to change the settings to be able to test the triode section. So I got to change some of the dials, and I'll be right back. Okay, we're going to heat the tube back up, and this one we're going to just direct read it. There's no multiplication. This is the triode section of this. This is a dual tube. It has a triode and a pentode in the same case, and this is the tube at the very end that we use for the final preamp gain and the phase splitter, which is going to drive the output tubes. So this is a very important tube, and like I said, it's a rare tube. You know, they don't make them anymore, so you got to get new old stock, and they're getting kind of pricey. So hopefully if this triode's good, the tube is good. And we need at least 1400, and we've got, looks like 2100. I can't quite see. Yeah, a little over 2000. So good news, our 7199 is good. Now let's say that the 7199 was not good. What would we do? Well, there's a couple options. You can use a 6U8. There's a couple other tubes that are the 6CG7, 6U8, the what is it, 6678 or something like that. I don't remember. There's 3 or 4 different tubes that if you rewired a couple of the pins, they will be a suitable substitute, and they are more readily available and less expensive. So if this tube were bad, that's what I would have done. But as it is, this one's good. We're going to use it and continue to use it. Should last a long time. Okay, everything's finalized here with the bias circuit, and now I'll give you the secret formula for the secret sauce here. I ended up changing the bias resistor from 33K to 68K, and I ended up changing the dropping capacitor from a 0.033 to a 0.0047, or a 4.7 nanofarad at 1000 volts. I also dropped the capacitor, because it was too sluggish, from 100 microfarad to 10 microfarad, and the bias circuit is absolutely perfect. The balance pot works great. The bias is sitting right around the middle of the travel of the pot, and right now this doesn't mean a whole lot to you at the moment, but if you notice, I have my 2 voltmeters are reading about 7.5 volts, 7.7 volts. Let's talk a little bit about why we're concerned with that particular voltage. Alright, the first thing we want to take a look at is the tube chart for the 7591 tube. So here I just kind of printed it out, and this is a push-pull amplifier, class AB1. It's pentode connected, and we're using fixed bias. And we have somewhere around 435 volts, so it's right between this 400 and 450 volt chart. And if we go through and look at some of the specs, your grid bias, to bias it to this to the correct current, is going to be somewhere around negative 16 to negative 17 volts roughly, and that can vary a couple of volts plus or minus. The zero signal plate current, and this is what we really are interested in, this is our bias current, and you can see it's anywhere from 77 down to 66 milliamps, so somewhere around that 70 milliamp range. And how are we going to calculate that? Well, there's several ways to do it, but my favorite is by calculating the drop across the audio output transformer. So here is a not perfect schematic. This is not exactly anatomically correct to what we have, but it's very close. And really, for the part we're interested in, this is good enough. If you look, here's your transformer, and this point A is connected down to point A, which is the direct output of your power supply. So that's your 435 volts right there. If I measure from here to here, this is from the center tap to this winding, and from the center tap to this end of the winding, I can read an actual DC resistance. When I measured this transformer in particular, each side is about 123 ohms. Alright, now if we use Ohm's law and we take V, voltage, equals current times resistance, and let's say we want a target value of somewhere around 70 milliamps, because it was between 66 and 77 milliamps for our idle current. So let's say 70 milliamps, 0.07, which is 70 milliamps, times 123 ohms is going to give you about 8.5 volts, 8.61 volts. So if I have 8.61 volts from here to here, or from here to here, it's safe to assume that you have about 70 milliamps of current flowing through this tube. So, which is right around what they want. So that's if you want to run the tubes at their normal ratings. Now I like to run them a little cooler because that'll make them last longer. Now if you run a tube hotter, it'll break up a little different, it'll give you a different sound. But if you want the tubes to last longer, you can bias them a little bit cooler and they'll last a little bit longer. So we want somewhere, I chose a target voltage of around between 7.5 and 8 volts. So what we do is we take our voltmeter and we go from pin 3, which is our plate, our anode. So we take the anode wire of the transformer and we measure it in reference to the input voltage, or the center tap of that transformer. So if you look over here, here's the red wire down here. It's kind of hard to see, but there's your red wire, and that leads right to that center tap of the transformer, and I have my voltmeter leads right there. Then I take my other voltmeter lead, and you can do this with 1 meter and just move the probe. If you have 2 meters, you could check both tubes at the same time, which is kind of what I'm doing. And here is the other end of the winding for this side and the other end of the winding for this side. So your blue and black and brown wires. Now, when I measure that voltage drop, all I want to do is adjust my bias pot till I get my 7.5 to 8 volts for my idle current. Then the other thing I'm concerned with is that they are balanced to one another. By slightly floating these cathodes a little bit above ground, that allows us to do just a slight trimming to balance the two tubes if they're not perfect. So the next thing you're going to do is we don't care exactly the voltage, but we just adjust this pot down here, the balance pot, until both of the meters are equal. Once they're equal, then you can fine-tune your bias again to get your voltage right where you want it, right around that 8-volt mark or that 7.5-volt mark, wherever you want it to be. I tuned mine in at about 7.5, 7.6 volts, both tubes. And tubes change as they heat up, and as the environment around them heats up, and as all the components in the circuit heat up. Little things change. So this has to be done over about a 10 or 15 minute period of time at least. If the amp isn't on for at least 10 or 15 minutes to kind of stabilize, you'll notice that that bias will drift a little bit, and that's normal. It's going to do that. We're concerned about where it settles down after everything is at its normal ambient operating temperature. So that's what we adjust. So if I turn the power on, as the amp heats up, you're going to see now these tubes have cooled down, so it's not going to be perfect. But you can see as the tubes warm up, that voltage is going to climb, and that's your DC across your DC resistance. And you can see they're sitting a little bit low now, and what's going to happen is if we leave this on for about 5 or 10 minutes, this will just slowly creep up, and then it will eventually settle. And it's going to settle somewhere in that 7.5 to 8 volt range, which is where we want. And it's as simple as that. The other thing is that 500 volts that we were seeing earlier on our power supply is now dropping down to about 435 volts, which is respectable. So there you go. Our output section of the amplifier is completely done, and we're ready to start looking at the rest of the amp. So I'm going to close out this video right here at this point, because I think this is a good stopping point. This is probably a really long video already, and then in the next video we'll actually look at the preamp and the front end of this amplifier and look at some of the things going on with it. So I hope you enjoyed this as much as I did. It was a lot of fun rebuilding this. I don't work on a whole lot of guitar amps anymore, but I really enjoy it when I do. So anyways, thank you all. As always, peace, joy, happiness, and good health in your lives. And like I said, my videos are a little bit slower coming these days. They postponed my surgery another week, so now I'm having it this week instead of last week. So I'll be down for a few days, but don't worry, I'll be back. Anyways, that's it. We'll be back for next video. Be well.